Here's the thing about plants that isn't taught in school. They're actually pretty bad at photosynthesis. I'm going to teach you how scientists are fixing this through reverse engineering cyanobacteria. Plants rely on rubisco, a tiny molecular engine that speeds up reactions. It has a docking station where it first binds a starter sugar called RUBP, then captures CO2 and chemically glues them together, starting carbon fixation. However, oxygen competes with CO2 for the same spot in rubisco. When oxygen wins, rubisco triggers photorespiration, a process that burns energy and releases CO2 instead of fixing it. Often, this side reaction can steal a big share of rubisco's activity, slowing photosynthesis and plant growth. It turns out that cyanobacteria have the solution. They build tiny greenhouse-like structures called carboxysomes. Just like a greenhouse traps sunlight inside so plants can thrive, a carboxysome traps CO2 inside so rubisco can thrive. Here's how. Cyanobacteria pump in a kind of CO2 that's been dissolved into water called bicarbonate. Once inside the carboxysome, a different molecular engine called carbonic anhydrase flips bicarbonate back into pure CO2. Because the CO2 can't escape, it builds up, letting rubisco work in a CO2-rich bubble, safe from oxygen. And now, the breakthrough that changes everything. Carbonic anhydrase is activated by RUBP, the very same sugar that rubisco needs. When RUBP is abundant, it cranks up carbonic anhydrase activity, producing more CO2 exactly when carbon fixation is ready to happen. This creates a synced system where RUBP signals how much CO2 to supply. If we can bring carboxysomes into crops, plants could produce more food and pull more CO2 from the atmosphere while wasting less energy. By reverse engineering cyanobacteria, scientists are creating something that never existed before: carbon-gobbling super plants.